So we've looked at tangent, now it's time to look at cotangent. So reminder that cotangent is cosine over sine. This means that anytime the graph of sine has a 0, aka crossing the midline, cotangent is going to be undefined. It's going to have a vertical asymptote. So we basically flip-flop what we did, everything in the tangent video, but now we're going to do it with sine. So every 0 or midline point on sine becomes an asymptote on cotangent, and between the asymptotes, cotangent looks like a snake. This time, though, positive cotangent snakes down, negative cotangent snakes up. So that's kind of counterintuitive. That's a thing to definitely work on memorizing. So everywhere my beautiful sine graph hits a 0, we have an asymptote. Let me draw my midline in here, which happens to be the x-axis. On the midline, equally between your asymptotes, is your point of inflection, and I'm just graphing a positive cotangent, so we snake down. So let's look at these examples. They may look oddly like the examples we just did with tangent, but now they're cotangent. So we'll start with factoring out and dealing with any negative b's. So factor out the 2 minus 1. I have a happy positive b, so I don't need to worry about even or odd. Then we're going to fill in our table. Cotangent, I'm thinking sine. So 2 sine of 2x minus pi over 2 minus 1. So we have amplitude 2, period pi, phase shift right pi over 2, midline of negative 1. Go in pi's over 2. And right pi over 2. And down 1. Up my amplitude, down my amplitude, run for my period. I left enough room to do it twice. And now instead of thinking about cosine, we're going to think about sine. Begin and ends on your midline. Middle's on your midline. Goes up, goes down. The up and down doesn't matter on tangent and cotangent. But I'll just put it there. So every spot I have something on my midline is going to be an asymptote. Once again, that's because it would be making cotangent have a denominator of 0, which makes it undefined. Then I go on the midline equally between the vertical asymptotes. That's my point of inflection. And we're dealing with positive cotangent, which snakes down. Notice it's only taking a width of pi over 2 to repeat. That's because it's taking my period of sine or cosine and cutting it in half. It repeats in half the time. Let's try another one. Once again, this one should look oddly familiar, like the one we just did. Let's deal with our factoring first. Factor out your negative pi, x minus 3 over 2 plus 1. Now what we need to know is that cotangent is odd. So same thing is going to happen with tangent. That is going to come out once again. If you're in standard pre-cal, just pretend you didn't see that. Just know it's negative 1/2 cotangent. I wouldn't ask you to do that. And now we're going to fill in our table based on if this was sine, since we're dealing with cotangent. I'm going to go fast on this part since we did the exact same thing already. Period of 2, phase shift 3/2, midline of 1. So I scaled this the same way we did in our tangent video. And we need to go right 3 over 2, up 1, up amplitude, down amplitude, run for your period of 2. We're doing sine. What I really need are these 3 points, but if it makes you feel happy to do your negative sign, there you go. Anywhere that sine has a 0, aka has your midline. I'll do another one just for good fun. Is where you're going to have an asymptote, go equally between the asymptotes on your midline, and you have your point of inflection. Negative cotangent snakes up. Okay, it's weird. Negative is going up. And we're done. Honors try to do the analysis of this graph.